Hello. Okay, we're a minute late or so because there we go. We're a minute late or so because things have decided not to work, but now they are. So before we get started, hello, my name is Scott. I'm instructor at the University of South Florida. This is Discrete Math, and today is the 10th of September. I think I've said what I'm supposed to say. So yesterday, while I was about to teach calculus, on this beautiful platform. Something happened where, there was a big thunderstorm, flash of lightning, crash of thunder, down goes my power. Storm knocked out my power, and my backup internet didn't work. So just in case that happens in the middle of class or something and I get disconnected, what I've got, usually my cell phone works. So what I'll do if that happens is I'll make an announcement. I'll get on Discord as quickly as possible on my cell phone. Because I'm already on it on my cell phone. It shouldn't be that powerful long. And I'll tell you how we're going to proceed. I did get this little toy yesterday, which is supposed to enable me to connect to the internet through this jetpack thing. But then I tested its up, and I'm not sure if its up speed is quite up to its down speed was fine. Its down speed, I could stream Netflix. But its up speed was not quite up to snuff, probably for streaming. But we will see. Push comes to shove, I can keep going later. I can continue the lecture later, or I could just post it on YouTube. I'd rather do it live, obviously. So there is a backup plan. So just in case something happens, and I get disconnected, there is a backup plan. There's actually 3, but all of them failed yesterday. Anyway, how's everybody doing? I should be doing this. For some reason, I can't see the Discord window now. I don't know why that is. Yes, people are suggesting that I Instagram it. Okay. So as usual, there is public. Discord, not Discord, Twitch chat over there where you can ask questions. I'm doing great. As you can see, I'm kind of not in it hasn't been one of those days where I've gotten everything organized and I'm wearing a nice shirt. It's kind of a medium shirt day, It's also a little hot in here, because there's these lights and the AC just can't keep up. But anyway, I'm awesome. Thank you for asking. So, as usual, there is Discord chat that way. And there is also, not Discord chat, there's Twitch chat over there where you can ask questions and everything. And then there is Discord chat. If you are on Discord, you can ask questions that only the class can see. If you're on Twitch, you are, of course, asking questions that the whole world can see. If the whole world cared to watch my lecture, which, on Twitch, which they probably don't. People are asking me what's my favorite band and things like that. I think those are questions that we should not address at the moment. Though, if you had to press me, I'd probably say Nirvana, but that's a generational thing. Okay, so that's enough of that. So anyway, we had a quiz, and we had some difficulty on the quiz. People were asking questions. This was one of those quizzes where I wanted you to figure things out. Now, questions like this can show up on the test. Of course, I don't want you to. The point is that you figure them out for the quiz, and then when they show up on the test, you know how to do them. Quizzes are really homework in a way, right? Because I make you take them as quizzes using Factorial, but they don't. Also, I made an announcement about this. I told the TA to be super strict with all the Proctorio things, and she was, like I asked. Unfortunately, you guys get to see who the TA was because we're all remote, and she wasn't able to sit in my office and just do it so that you had to respond to me. Please don't ask the TA about it. The TA was following my instructions. If you are concerned about Proctorio, by all means, talk to me about it on Discord during office hours. You can send me a message outside office hours. I don't always respond right away. I usually respond faster to Discord messages than I do to emails. Or comment on the thing itself. But don't ask her questions about it. She's been following my orders. So if you have issues with, we're trying to iron out all of the issues before the test, if that makes any sense. So again, don't bother the TAs. Bother me. We're trying to iron out everything before the test. I hate Factorio. You hate Factorio. We all are on board with this idea about hating Factorio. So don't, what? It works for everybody else. No, it doesn't. It doesn't even work for me. All the time I'm adding a quiz question and Factorio will crap because Factorio has to be active on my side in order to make the quizzes. Yeah, I can't just turn on Factorio on the thing. I have to have the browser extension installed, and it saves in the stupidest way. It saves everything like locally, so if I have to uninstall and then reinstall Factorio, it destroys all my settings. All the settings for the quizzes. I have to keep it going and redo them. Stupid program. But it is what we have. They paid way too much money for it, so we're going to use it. So yeah. Okay, so enough about that stuff. Let's get to the quiz. Everyone hates Factorio. We all get on board with that, and I've wasted 7 minutes. Okay, so about the quiz. So the setup is this. I've got 2 piles of cards, right? I got a pile of 9 cards, a pile of 7 cards. I should say I've got a set. It's more like, the dealer has done cards that are shared in the pool like you do in Texas Hold'em. And your hand is determined by the cards that are both in the common area and then in your hand as well. So I've got 3 cards in common between sets A and sets B. So, and the point of this thing is a little bit of abstraction. Now it's not particular cards I'm interested in. Now I'm after properties of these sets that are based solely on the size of the set. Okay, so it doesn't matter if we're talking about cards, we're talking about Legos, whatever we're doing. We've got a set of objects, and we just want to talk about properties that they have by virtue of the fact that they are a certain size. Okay, so the size of the set A intersect B is 3. I said so. And now I want to know how many pairs can I form from these 3 cards? Well, the answer is, I take the size of A intersect B, choose 2, which is 3, choose 2, which is 3, right? How do we feel about that question 1 to 5, that first question? All right. All right, so we feel pretty good about that. Some people don't. For some people, the notation scared you, and the kind of complex thing. If I had put 3, choose 2 there, or if I had done A, choose 2, the size of A, choose 2, that would have been 9, choose 2. But this idea of having the intersection kind of 3 people, and then 3, choose 3 is 2 is 3, right? It's the number of pairs, and it's equal to 3, choose 1. That's how you can quickly get that one. Okay. All right. Well, the second one. So it's not 3 factorial. I mean, it is 3 factorial over 2, but that's not where it came from. It came from the fact that it was 3 falls 2. It was 3 times 2 over 2 factorial, right? And 3 times 2 over 2 factorial, which is 3 times 2 over 2, is 3. So you could have done it that way as well. 3 falls 2 over 2 factorial, but of course, that's the same thing as 3 factorial over 2 factorial, but that's incidental. That is that, right? That's because it's 3. 3 falls 2 is the same thing as 3 factorial. I mean, they're not the same thing, but they will come up with the same number because that last number is just 1. But they aren't the same thing. They're equal, but not the same. If that makes sense. I probably just made it more confusing. Okay. A union B, you have the formula for this. It's A is the size of A plus the size of B minus the size of their intersection, right? So if I take the size of A and add it to the size of B, I've overcounted by A intersect B. So I have to subtract one copy of A intersect B. How do we feel about that one, 1 to 5? Okay. All right. Let me just check Discord chat here. 3 falls 2 is that symbol. There's a question in chat. So the formula, we call this formula for this thing. 3 choose 2 equals 3 falls 2 over 2 factorial. And remember, that comes from this little proof that we did one time, which was that n choose k equals, I'm sorry, I order so I choose the set and then I count how many number of ways to order them, and then, or I just do it to begin with. And that gives us this formula, n false k over k factorial. And we call that like, let me give you an example, like 5 false 3. Oops, I always do that the wrong way. 5 false 3 equals 5 times 4 times 3. So I'm going to get 3 items. 10 false 3 would equal 10 times 9 times 8. That's 3 things. So I do the factorial, but I'm only, oops, that shouldn't be a parentheses there. I'm only going down, and I know it's over my head. I'm only going down a little bit. Right? It's like the factorial, except I stop. That's the falling factorial. Okay. And then the 2 factorial, so 10 factorial, this symbol would be the following. 10 factorial would equal 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which is the same thing as 10 false 10. So it's basically a special notation when this number and that number are the same. Okay. Now, this next one, I didn't give you a formula for this, so you kind of had to work it out. I guess you could have looked online for the formula, but that's what it is. Now, people were confusing this for set difference with symmetric difference. So 2 different things. Okay, and I didn't want to do symmetric difference, but it was in the book, and it's on that list of things that I'm supposed to cover, along with some stuff that I'm just not going to. So I did it. But the set difference, this is stuff that's A minus B, is stuff that's in A that is not also in B. Okay? So when I draw the Venn diagram, this is A, this is B. Like, I'm using my finger as if you could actually see that. This is A and this is B, right? So if I'm doing the Venn diagram, what I want is this section right here. Well, when I count this, if I subtract all of B, I'm going to over subtract. But if I only subtract the intersection, I've actually subtracted the correct amount. So what I'm going to do is I'm going to take the size of B and I'm going to subtract out the things they have in common, and I'll wind up with 6 elements. So how do we feel about that, 1 to 5? All right. It was one you had to figure out. Okay, for part D, it's 9 times 7 equals 63. If you got 52, your multiplication wasn't very good. If you got 36, that's your dyslexia, creeping. I mean, dyslexia, creeping in again. So, how do we feel about D 1 to 5? All right, so I got a couple people that are unhappy with figuring out this one. And if that doesn't make sense, you kind of have to play with it. But if it doesn't make sense, come talk to me during office hours. Let's talk about it. Because that was one of those I'm trying to get you to kind of figure it out. So hence the hint. Use a Venn diagram. Okay. All right. Now the code. So I gave you a piece of code, and I asked you to figure out what was going on. So there were a couple of ideas about this. Okay, it's a difficult problem, but you can figure it out. And of course, I formatted it in such a way on the quiz that you should have been able to copy and paste the code. And the idea, which ties into what we did last time for problem set 2 and ties into problem set 3, is to figure out what the computer is doing. Okay? So, what I kind of wanted you to do, I can show you this. There we go. What I kind of wanted you to do was kind of take the code and figure out, and I didn't just want you to count what it was doing. I wanted you to kind of figure out what was going on. So, if I pull it up here, here's the code. And you'll notice here what I've done is I've added these kind of lines here. Let me actually, I've added this a little bit. So what I wanted to do is every time it runs through, I want it to tell me what it's doing. So I'm going to add these like print lines. I'm going to tell it to print I equals, and then tell me what I was. Oops, wrong thing. So every time it runs through this, I want it to tell me what's going on. Well, let me get rid of this so it's back to what it was before. Okay. So what's going to happen here is this is called debug code. And debug code is stuff that you take out of your final script, but you have it in your code while you're trying to make the code work. I mean, okay, so people will yell at me, purist and comp sci are going to yell at me for the way that I've done this because I haven't, used special debug command or something like that, or a special debug parameter so these only print when you do the debug. No, I'm going to comment them out, right? We're IT people. We're not computer science type people, okay? We do things that work. So what I'm going to do is I'm going to run this little piece of code. So this is boost solution hint. When I run this little piece of code, it's going to tell me here what's going on. Well, the array is going over 1, 2, 3, 4, and it's actually every time it loops. You see here, it's doing for every I in A. One of the disadvantages of PHP as opposed to Python, although I hate Python with a fiery passion, is Python reverses these. They actually have for every I in A. But in PHP, you reverse that. You do the array first, and then you do the thing that you're going to assign the array to, right? So this is the variable it's assigning. Every time it loops through here, it says I equals 1, and then it prints jam. And then it says, okay, now I equals 2, because I reached the end of the loop, and it prints jam. And then I equals 3, and it prints jam. And then I equals 4, and it prints jam. So how do we feel about that 1 to 5? That it's going to print 4 times. Once for each I in A. Oops. Now I've lost the window again. All right. And yes, so I ran the script. I put in here, inside the double loop, I actually printed what it would come out to be, right? So every time it runs the loop, I wanted to see what the computer would do. So here's what the computer did when I ran the script, right? I equals 1, j equals 1 foo. And then notice here, it's on the inner loop. Once it enters this loop, and then it enters this loop, and it's in the inner loop. So it's going to stay here until it finishes these loops. Okay? So it's going to stay here until it gets all the way through, right? So it's going to go I1, J1, foo. I1, J2, it's here. 3, 4, J here. Now when J reaches 4, it concludes this loop and goes here. This thing says we'll go back to the loop and go to the next index. So now it comes up here and it goes, okay, now I'm 2. And then it comes back here and it goes, okay, now I equals 2, J, I'm starting this loop over again, J equals 1. So I equals 2, J equals 1, 2, 2, 2, 3, 2, 4, close, loop, enter, right? Loop, I equals 3, 3, 1, 3, 2, 3, 3, 3, 4, 4, 1, 4, 2. So how do we feel up 1 to 5 about what the computer's doing? Okay. So, and you can see that that's the point of printing out this statement. Okay? And it's exactly like A cross B. In fact, it is A cross B, right? If I structure a loop this way, a nested loop like this on the same set, if I structure it this way on the same set, it's going to run over every ordered pair. 1, 1, 1, 2, 1, 3, 1, 4, 2, 1, 2, 2, 2, 3, 2, 4. It's going to loop over every ordered pair of A cross B. Okay? Yeah, so it goes inner. The inner is the thing, right? So it starts out here, but then it does this. So it does, okay, I equals 1. Now I'm going into a for loop. Okay, I equals 1. Now I'm starting this B thing. The first element is 1. So now it's going to go, okay, I'm 1. And then it's going to go, okay, I'm 2. I'm 3. I is still 1 because I is just hanging out here. I doesn't increment until this loop runs all the way through. And then I increments. And then this loop runs all the way through again. And then I increments. This loop runs all the way through again. And then I increments. And then this loop runs all the way again. So the point is, if what I want to do is loop over a cross product, that's how I do it. The next one's a little bit slicker. How do we feel about that 1 to 5? What the computer's doing and why? Right? So just the feel of the computer. And then there's this idea that what I want to do is I want to insert these debug codes. Okay? So I want to, I want to just insert debug code to kind of figure out what the computer's doing. And, if somebody's yelling at you, oh, don't do that for debug code, right? If I want to get rid of this code, I just sit here and I comment it out. So that's why if you see my scripts, right? Here's one of my scripts, check times. Look at all this debug code that's in here, right? This is what I did, right? I had this print current column thing where I was trying to figure out how to make it work and make sure it was working. And then I had the, let's make sure that the CSV thing is working. So, I had a code here to print recursively the current staff array. And then when I was doing the current staff array, I wanted to make sure I was doing the right column. So I printed that out. And then you can see that I just, when I got it to work right, I just, commented out the code. And that's how I wrote my script. So yeah, it's debug code. Right. I mean, purists are going to tell you that you're supposed to use like classes to do that, right? So you're supposed to have like a debug mode and a test mode that, you don't print unless it's in test mode or debug mode. Shut up. We're not building Microsoft Windows here, although I'm sure the guys who build Microsoft Windows are probably doing this too. We're not getting yelled at for the beauty of our source code. We want it to work. And we want to be able to connect the code to the math. All right. Next bit here. This one's interesting. This one, notice I've added the line of debug code. This is going to do something interesting. It's going to, for everything in I and everything in B, and notice that A and B are the exact same array. In fact, if I replace this with A, it'll run perfectly fine. Okay. It's going to print only if I is less than J, right? So if I equals 1, J equals 1, it doesn't print. If I equals 2, J equals 2, it prints. It prints. So it's going to print 3 times on the first run, twice on the second run, and once on the third. So 3 plus 2 plus 1. 6. But it also does something even more interesting. So how do we feel about that 1 to 5? Yeah, there is. There is a more streamlined way to figure it out. And that requires a slightly different perspective. So people are asking, is there another way to figure that out? And the answer is yes. Where'd it go? Okay. So let's look at this. Let's again consider the ordered pair IJ. And notice it's not going to print for these orange things, but it is going to print for the highlighted blue ones. So I guess they're green now because I had blue and then I put yellow highlighter on top of them. But notice what this is, right? Notice what the highlighted pairs are. If I instead considered 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, and 2, 5, I've actually enumerated every element of A choose 2. Right? I've enumerated every pair with no repeats. Right? I've enumerated all the pairs in the sense of a set, right? All the pairs of cards. If I had 4 cards and I numbered them 1, 2, 3, 4, I will have enumerated all the ways to form a pair from 1, 2, 3, 4. Okay? And that means that what I've done is actually A choose 2. So 4 choose 2 is the answer. Because I've enumerated this set. Okay? So how do we feel about that 1 to 5? And remember that the point of these things is to figure it out, right? This is, I mean, I call it a quiz, but it's kind of really homework, right? I want you to figure these things out. But so 4 choose 2 equals 16. And note what I did in the code. This is this idea. I'm looping over a set. I'm looping over a set here, right? If I make all of these A, the same thing happens, right? Because I'm just looping over the same set. So let me show you that it doesn't matter. B is superfluous in this whole thing. I'm going to get rid of B and the code is still going to work exactly the same way. Right? The code is exactly the same. I can enumerate over the same set, right? But when I enumerate over the set, I'm actually enumerating over A choose 2. And the way I did that was I only did the indices where I was less than J. And that's, if I want to enumerate over the pairs in an array, that's the way I write the loop. That's the whole point, is that this is the way I write the loop. I'm sitting here pointing at the screen like you can see it, right? You can see my finger pointing at the screen. No, I need to move the mouse. Look at this here. The whole point is that if I want to enumerate all elements of A choose 2, this is how I do it. And that's the whole point. And then you could do other tricks to do like A choose 3, A choose 4, the triples and so forth. But A choose 2 is a lot of times what we want to do, right? So when I was writing that program to enumerate over all of the possible pairs of training times, remember from the very first lecture, or maybe it was the second lecture, I wanted to write a script that enumerated all of the things and checked to see if I could get a pair of times, right, that would work for everybody and for all of the peer leaders. So when I did that, notice here, I've got where do I have that little piece of code? Where is that while loop? While column 1 is this, while column 2 is less than or equal to num columns, current column equals that. And that's how I did it. I basically used that same cheat. Now, granted, there's a little bit more into this, but that's basically what I was doing. And that's how you enumerate over the set of ordered pairs. So how do we feel about that 1 to 5? This idea that I can write a loop that will enumerate the ordered pairs. All right. And it's a really cool trick that you're going to want to remember when you're, writing scripts for your job. Okay, so what are the takeaways? The takeaways are the following. And let me get back to the tablet here. The takeaways are the following. If I want to write a script that runs over the pairs in a set, I create a nested loop and I run the command where I is less than j. Other takeaway. When you want to figure out what a program is doing, add some debug code and have the computer print the variables, the values in the variables to the console. All right. So how are we doing? 1 to 5 on those kind of 2 big takeaways from this quiz. When you want to figure it out, add a little debug code. When you want to create a nested loop, do a pair. When you want to enumerate over pairs, do a nested loop so that I is less than j. Okay. How do you add the debug code? You just write it in, right? Print this semicolon enter. You just add it. You just write, print, var_dump are nice codes. Var_dump is always a nice thing. So you just add, you can't see what I'm looking at because I don't have it up, right? You just add these lines. Var_dump is nice. Print is nice. Literal, I think, is the one you have to use in the truth table one. Yeah, var export is nice. All of those things. All right, are there any questions before we flip on over to the content for today? All right. Okay. Discord chat. What was with that first question? Which is the first question you were referring to? 3 choose 2. Yes, that is exactly what that is. So that first question, the question is what was with it? 3 choose 3, 2, yes, is 3. So that was the point of that question. It was to, you kind of had an A intersect B. This is a set itself, right? A cat B is a set. And I want to know how big the set of ordered pairs from that set is. So if I had queen, king, 10, right? How many ways are there to form a pair from these 3 cards? And the answer is there's 3. So that was that. Okay. All right. So that seems to be the last of those questions. Some of you are angry for me throwing you off, and I'm okay with that. Right. I mean, at some point you can only get so hurt by that. So this was the we were doing truth tables last time. Let's finish truth tables off and let's do the formal definition of a function. There's questions about what's going to be on the test. I will be posting a test review, but the big thing that you're going to want to know for the test is you're going to want to practice your old quizzes. Because basically what I'm going to do is I'm going to take the quiz questions, I'm going to throw them together, I'm going to change a few numbers, change the size of some sats, and then I'm going to put it together and make it a test. Because, actually doing all that work of making up new questions, that's just too much work, right? Especially since you have to code them into the... especially since I have to code them all into Canvas, and that's just annoying. All right. So last time we did the and this was or. And I made the point that slightly different from normal language. All right. And I made that point last time. And the easiest way to think about truth tables is to make two propositions, right? So let P be I went to the store. Q be I went to the movies. Obviously, I did all of this last year before coronavirus. Well, I went to the store, right? I haven't been to the movies since COVID. Actually, I haven't been in the movies since like a year before COVID. So this is P, this is Q. So if I went to the movies, and it's true that I went to the grocery store, then it's true that I both went to the grocery store and I went to the movies. If I didn't do one of them, then of course the combined one is false. And or, which is slightly different, is, I went to the grocery store or I went to the movies. Well, if someone said that and you did both, they may, they may not like you. Okay. Which brings us to our next kind of logical operator. This is one of those ones that's in orange because I don't want to cover it, but it's in the book. So I should. Is the exclusive or. Which is the same as exclusive or, which should have a smaller pen because that's horrible. Right, the exclusive or, and you sometimes see it as this thing. You also see it as this thing right here. What was the other symbol for it? Yeah, it's usually this. Sometimes you see this. There's various symbols for it. Who cares? Because I won't. I hate it. But the exclusive or is one or the other, but not both. So if I wanted to draw a truth table for the exclusive or, what would it look like? Oops, I didn't want to move it. I wanted to copy it. So if I wanted a truth table for this, what would it look like? What would be the difference between this truth table and that truth table? All right, there's only one thing difference. This is false. Okay. But again, I don't care. Because it's, oops, this should be an exclusive or. And you see different things. You also see this thing, this V hat thing. I'm not a big fan of it. And if I ever put it on a test, I would tell you this is the exclusive or. I wouldn't give you a symbol. Okay. All right, let's talk about not. So this one here, it's these two are, this is what's called a unitary operator. It only takes one variable. This is P, and this is not P. And not simply changes. So true becomes false, and false becomes true. Now, what about not P? What happens there? And this is very different. It's not different than English. English is a very, we're going to be logical. At least the Queen's English is we're going to be logical in language. But most languages are not like this. And slangs of, if I say, in French, jamais, jamais, I'm never, never. That means something, that means I'm really not going to do it, right? Not is additive in most languages, but not in English and not in logic. In logic and in English, it's multiplicative. So if I have let's examine the statement not P. And let's do these truth tables here. So I'm first going to do this. So I've got P is true and P is false. Well, not P would be false. And then it'd be true. Right? Because it changes the truth value. Well, not P, I'm now going to take this truth table. I'm going to basically hide this truth table. That one no longer exists. Right? The line with P no longer exists. Okay? And then what I'm going to do is I'm going to do not P. Well, this is true, and this is false. And so by truth table, P is the same thing as not P. So it's like a double negative, except in every other language but English, a double negative means more negative. But in logic and in the Queen's English, right, and in all the slang Englishes that you go around, like Cornish or whatever, it's or Scots, a double negative is more negative, right? It's something weird about standard English. So it's Cornish is a dialogue of English. As in Cornwall, in the UK. So in all the slangs for English, a double negative is additive. But in the Queen's English, as I said, English is a weird language. So double negative is positive. Okay. All right, so we had a couple of other ones. And it should be noted that things are either true or false. Okay? And that gives us some weird things. What about this? P implies Q. What about this? Let's pull up a truth table for that, right? Let P be, P is going to the store, and Q is, that's a G, Q is buying orange juice. It's Florida. We buy orange juice. Okay. So let's look at this truth table. Actually, I only want one line there. So I say to you, if I go to the store, I'm going to buy orange juice. Okay? If I go to the store, then I'm going to buy orange juice. That's what P. Now, if I went to the store and I bought orange juice, am I a liar? If I went to the store and I bought orange juice, am I a liar? No, it's true, right? The fact that if I go to the store, I will buy orange juice. If I went to the store and I bought orange juice, what I said was true. Now, suppose instead that I went to the store, but I didn't buy orange juice. Am I a liar? Right? Yes. I went to the store, but I didn't buy orange juice. But I said if I was going to go to the store, I'm going to buy orange juice. So I lied. Now, if I went to the store, if I didn't go to the store, but I bought orange juice, let's hold off on that. Let's suppose instead that I didn't go to the store and I didn't buy orange juice. Did I lie? I said to you, if I go to the store, I will buy orange juice. I didn't go to the store and I didn't buy orange juice. Am I lying? The answer is no, right? Because I didn't go to the store. I said, if I was going to go to the store, I will buy orange juice. I didn't go to the store. Therefore, I didn't go to the store and I didn't buy orange juice. That's fine. So I did not lie. So when I say true, the question is, am I lying? Well, the question is, am I telling the truth? Now, if it's not true so if I didn't go to the store, but I bought orange juice, am I lying? I didn't go to the store and I still bought orange juice. I told you before, if I go to the store, I will buy orange juice. I didn't go to the store, but I still bought orange juice. I went to the gas station, or I went to the farmer's market, or I grabbed some out of the caterer that brought us lunch at the office had orange juice, and there was a leftover carton, so I grabbed that instead. And the answer is no, I didn't lie. Right? I said if I was going to the store, I was going to buy orange juice. I showed up with orange juice. But I didn't lie to you. I didn't tell you that if I didn't go to the store, I wouldn't buy orange juice. I simply said that if I went to the store, I would buy orange juice. So this right here is the truth table for P implies Q. Now, what about P if and only if Q? What changes? Now I'm saying if I go to the grocery store, I am only going to get orange juice if I go to the grocery store. So if I go to the grocery store, I'll grab orange juice. But if I don't go to the grocery store, I'm not going to get any. Right? I will get you orange juice if and only if I go to the grocery store. So if I don't go to the grocery store, but then I buy orange juice, I lied. Now, how do we feel about these two, 1 to 5? Okay. Now, I think that's all of the ones I did last time, right? Let's check. Yes. Okay. Now, this has a logical equivalency. This has 2, okay? Theorem. Proof with truth tables. Okay? If P implies Q, then not Q implies not P. This is called modus tollens. I think that's spelled correctly. Let me see. Or the counterpositive, Toolens. Technically, the rule of inference is modus tollens. Okay. Or the contrapositive. Let's just call it contrapositive. All right. If P implies Q, then not Q implies not P. Okay, let's prove it. Okay, so what am I going to do here? I've got two things here. I've got P and Q. And I got P implies Q. This is true, true. This should say P if and only if Q. Right, so my first one here, if I go back on my truth table, I see, dadgummit, stop that. Go away. So true, true for P implies true is true. True, false is false. False, true is true. And false, false is also true. I wasn't a liar. All right, same thing. Should be two lines here. Let's do the same thing for, so if I've got P and I've got Q, the next step in here, the inner thing, are these nots. So there's an order of precedence, is that not takes precedence over everything else. Okay, let's see. Yeah, so the symbol for not is that thing that looks like, this is the symbol for not. It's supposed to be longer. It's supposed to have a shorter tail. This is not. Okay. And that's a standard. All right, so what I'm going to do next is I want to evaluate not Q and not P. So what I'm going to do is I'm going to do not Q, and here I'm going to do not P. Now, the order of this doesn't matter. I'm just doing it because it'll be simpler for the next step to do it this way. Dadgummit, go away. I don't want my Windows security threats. Stupid Windows. Somebody make Linux have better tablet support. All right. Somebody do some coding. All right. So P is true. If P is true, 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 false, false, true, false, false. So if Q is true, not Q is false. If Q is false, not Q is true. If Q is true, not Q is false. If Q is false, not Q is true. If P is true, not P is false. If P is true, not P is false. And if P is false, not P is true. If P is false, not P is true. And now we do the last one. The last one was not Q implies not P. All right. So not Q is false and not P is false. Well, if I have false, false, right, this becomes true. False, false, through it a thing. I can think of this as R and this is S. And I could think of this as R implies S. Okay. So if R is true and S is false, then R implies less, I lied. If R is false and S is true, I told the truth. If R is true and S is true, R implies S is true. Now the proof is this thing right here. This and this are equivalent, right? So these lines here were the same, and these lines are the same. So they have the equivalent truth value. How do we feel about that 1 to 5? Okay. All right. So if you look at problem set 3, right, here is the truth table. Let's go ahead and run problem set 3 here. Oops, I'm in the wrong place. So if I run the code for problem set 3 that you see now, you'll see that this is the first one that I did. Right? This is that not P stuff. False, true, not P. Oh, this is screwed up. Why is it screwed up? Why is this screwed up? Oh, because part of the assignment is for you to fix it. Okay, so it's supposed to be screwed up. Okay. Yep, so this produced the truth tables for not, and then the to-do is for you to fix it so that it outputs correctly. Okay, so that makes me feel good. So here again is the truth table for P and Q. And then one of the things you're supposed to do is produce the one for OR. And now what you're supposed to do is produce a truth table for Q or not P. And the reason why I want to do that is because there's another theorem. By the way, these are equivalencies. So P implies Q. This should be if P implies Q is logically equivalent to. That's a better way to say that. By the way, I'm doing that here on Reflector. This should be is logically equivalent to. Okay. The next theorem is that P implies Q is logically equivalent to. to what? Is logically equivalent to Q or not P. All right. And I want you to work on that one. That's in the homework, is to produce that truth table for this one. So once you produce this truth table, you actually see that this one and this one are identical. Hey. Are there any questions about that? Yes. There she is. She showed up. It just started raining outside. Okay. Any questions, comments, issues, suggestions, thoughts? Okay. So are all the elements in the table before that still in the application? I believe you're asking this right here. So what I do here when I'm doing these is I label the two here, the P and the Q, right? I've got a logical operator that takes two things. And so what I've done is P and Q. Now, I've kind of said that this is R. And this is S. So I've said let R equal not Q and S equal not P. And so what I've done here is I've gone through them. I think that's your question. If I'm not answering it correctly, that's okay. So that's what I've done. All right, now let's talk about. I've got a few minutes left, which is good. I'm going to introduce the topic of functions. I'll nail it down with a bunch of examples next time. So there's an important thing going on here. Okay, and this is important. So computer people, so this is a math term. Function in this case is a math term. And this is the programming term. Okay, so this is programming. Okay. So there's a math term, and this is the formal definition. Okay. Let X and Y be sets, and let F be a subset of X cross Y. Okay. I'm going to have a little example up there. So what would be an example of a subset of x cross y? So let's say f equals the set of ordered pairs A1, B1. Okay? So I've said let x and y be sets and let f be a subset of x cross y. So f is a set of ordered pairs where the first coordinate comes from x, where the first item comes from x, and the second item comes from y. Okay? F is a function if. First thing that has to be true. For every x in big X, so this is a small x and that's a big X, there exists a y in big Y so that the pair xy is in F. Now let's look at our example over here. Is it the case that for every x, right, for every x in big X, there exists an element y in the set big Y so that the ordered pair xy is in F? So let's look at our sample over here. Is that true? If I have F equals A1, B1, this set, is it the case that for every x in X, there exists a y in Y so that xy is in F? Well, what do I need to check? Why won't it shrink down? It's just not responding to me at all. It's annoying. There it goes. Okay. Is this condition true for this set? Okay. Well, let's see. Let's check all of the x's. If x is A, is there an element in here that uses A? The first x. Let's do a loop. Let's check them both, right? Here's A. Is there a y in Y so that xy is in F? Well, yes, right? If I'm talking about A, there is a y, 1, so that A1 is in F. What about the other one, B? Is it true that there's some y so that B is in F? Well, yes, because B1 is in F. So, in other words, every x gets used. And then there's a second condition. For any distinct pairs for any two distinct elements of F, this is a x0, y0, x1, y1 in F, x0 does not equal x1. Okay, so how do we feel about those two conditions, 1 to 5? How do we feel about the first condition, 1 to 5? Let's ask that one first. First condition, 1 to 5. All right. Okay. Now the second condition, for any distinct elements in this, in other words, for all that's another way to write that. For any distinct elements of this in f, x0 does not equal x1. That means that no x was used more than once. Right? So is it the truth that if I pull this out, if I pull A1 and B1 out here, those are the only two elements of f, right? If I have A1 and B1, is it true that no x is used more than once? They can contain duplicates, right? I can duplicate the y, but I can't duplicate the x. And that's what's important. I have to use every x, and I can't use any more than once. All right, so I only used A once, and I only used B once. So f here is a function. This has another name. It's called the vertical line test. All right. If f is a function, then x is the domain of f, and y is the, nope, not range, target, or codomain of f. And we write f goes from x to y. And that's all it is. And the big takeaway here is that f is a set. Functions are sets. They are sets of ordered pairs. Okay, and that's it. That's what it is. Codomain and range are different things. Okay, so the range are the y's that actually get used, and I'll go into this next time. But y is the target. I don't have to use all the y's. Indeed, why won't this work? It scrolls, but it doesn't zoom out. I didn't use all the y's here, right? So I only used one of them. I only used the number 1, and that's legal. So codomain and range are not the same thing. Okay? They both refer to the Ys, but the range is the Ys that you actually hit. The codomain is the whole set of Ys. So the big takeaway is that in math, functions are just sets. And in computer programming, we're going to call them many-to-one relationships. Because that's what they are when you do them with a database. So don't think function as in something that outputs a value. Think of it more as a many-to-one relationship in a database. Okay, so today we went over truth tables. We did the basic truth tables, and then we did one proof using truth tables to show that two things were logically equivalent. I'm not going to do a ton with truth tables because I despise them, because they're boring, but they are useful for these like basic things. So if you want to prove some of these basic tautologies, they're very useful. So assignment 3, problem set 3, which you have, is actually all about making the computer generate the truth tables for you. So what you're going to do is you're going to create a bunch of loops with for eaches on the set true false, which is nice. And what you're going to do is you're going to create a bunch of loops. You're going to fix this loop here first. Not this one, this one. You're going to fix that so that it works. And then what you're going to do is you're going to make it so that you have a bunch of loops that generates the truth tables for you. And then you're going to make a truth table that generates this for you so that you can compare that to the implication P implies Q. So the whole point is to show that Q or not P is the same thing as P implies Q. But to make the computer do it, because we want to practice loops and we want the computer to make our truth tables. And the reason why these are very useful is because you're going to have conditions in your code that are going to look like this, right? P and Q, P or Q. You're going to want to do things not. The bang, by the way, is also for not in PHP. And you're going to want the computer to do these things. Okay, so that's the point of problem set 3, and that's the connection between problem set 3 and the math itself. Then what we talked about was, and then I talked about the formal definition of a function. Forget this little bit, although I may put it on the notes later. Where's my eraser? This little bit you can forget for the moment. I may put it in the notes later with a formal definition, another way to write the formal definition. But the important takeaway is that a function is just a set, and a function in math is something different than what you talk about when you talk about a function with computing. There's some overlap, but one of those is in math, we call what you call a function. In computing, we call that a procedure. So what we're talking about here is a function in math, or a many-to-one relationship. Are there any questions? I'm over, so by a lot. The last bit in red, the big takeaway. Functions are just sets of ordered pairs where every x is used and no x is used more than once. Okay. All right, perfect. Questions, comments, issues, suggestions, thoughts. Okay, so that is it for me. That is it for me today. I went a little bit over, and I'm sorry about that. Next time, I didn't write down what we're going to talk about next time. Next time, we're going to finish functions. And then we'll probably talk about the setup for number theory, because that's the next big thing is we're going to start the number theory stuff. But we're going to finish functions. We'll probably do quantifiers as well. We'll formalize quantifiers. And then we can start the number theory in module 2. Hey, we're on schedule. That's unheard of for me. Any other questions, comments, issues, suggestions, thoughts? Okay, so that's it. Thank you very much. I went 10 minutes over, not 15, so ha 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 ha. Oh, good question. So someone's asked in Discord whether the stuff for next week's lecture will be on the exam. The stuff on Monday will be in the exam, and I will have a study guide for you by Monday, but really, it's the quizzes. And then the stuff that we do, so the stuff that we do for the quiz on the Wednesday's quiz. So Wednesday's quiz is the cutoff. So everything that shows up on Wednesday's quiz is fair game. Everything that we talk about on Wednesday after the quiz is not. So everything after the quiz is going to be for the next test. So does that answer your question? It's Thursdays. I'm sorry, Thursdays. So today's quiz will be on the test. Monday's quiz will be on the test. And then, I'm sorry, not Monday's. Tuesday's quiz will be on the test. And then Thursday's quiz is on the test. So the stuff for Thursday's quiz. But the Thursday lecture material after the quiz is not on the test. And remember that the test is Friday and that you must attend at 12:30. That's the time the test is. Any other questions? All right. If you do have more questions and you type them in chat, I will answer them. Where'd it go? All right, and that's it.